In focused exercise 4.2, we're going to use data from a random sample generator to create a frequency distribution and a probability distribution. We will also interpret the results. The procedure is as follows. Number one, we're going to use StatCrunch to generate a random sample of 20 data points from a data set. So we'll need to open StatCrunch. I have my StatLab open, and StatCrunch should be listed on the left-hand column. So I'm going to choose StatCrunch. Now this may take a minute. We're going to open the data set from the textbook. So all I need to do is find that link and click. Now you can see the column on the left has all the available chapters in your ebook. We're going to go to Chapter 2. And we're going to look down the list under exercises for honey cough data. So that's bullet number 2. We're looking for honey cough data. And it is alphabetical, so that should make it easy to find. Here's the honey cough data. So I'm going to click to choose honey cough. The first column is labeled honey, so that is the honey cough data. And you can see that there are 35 observations for honey cough. Once you've located the honey cough column, we're going to choose data. So here above we have various tabs. Click on the data tab, and what we're trying to do is find a sample. There's sample, so we're going to choose sample, and then under select columns, we are concerned with honey cough, so we're going to select honey, and notice how that puts that in the box of our selections. We want a random sample size of 20, so I'm going to click on the box and enter 20. We only need to create one sample, so 1 is the default already. The default for storing is split across the columns, so that's already selected. So you should have selected honey for the column, sample size of 20, and number of samples is 1. Everything else in the default is selected for us. We are ready to compute, so that's in the lower right-hand corner. Click to compute, and notice how a new column has been created called sample honey. So we have our 20 sample points. So the next thing we're going to do is list the values that X may assume. So we're basically just copying these same values. So I'm going to list these values in order from lowest to highest. So StatCrunch can do that for us. All we have to do is click the Data tab. We're going to click Sort, and we're going to choose our honey sample, and we want that in ascending order, and compute. So you can click and shift these boxes out of the way, and now we have all of the same values that were randomly generated, but they're in an order that will make it easier for us to list. So our smallest value is 4, our largest value is 15. So we're going to go back over to the focused exercise page 4.2, and we're going to construct our table. The first column is going to be the X value, and then the second column will be the frequency, and the third column will be our probability. The X values range from 4 to 15, so I'm going to include every number between 4 and 15. The next thing I'm going to do is write down the frequency for each of those values. So I have one number 4, I have 1, 2, 3 number 8s. So notice there were no 5, 6, or 7, so I'm going to put 0 for those. We have 2 9s, we have 2 10s, we have 1 number 11, 5 number 12s, 2 number 13s, 1 number 14, and 3 number 15s. So if we add up each frequency, we should have a total of 20 because our sample is 20. So we have 1, 4, 6, 8, 9, 14, 16, 17, 20. So that's correct. The next thing we're going to do is figure out the probability The probability is calculated by taking the frequency divided by the total. So it might be good for us to include our total, and n is 20. So 1 divided by 20 is 0.05. So everywhere I have a frequency of 1, I know that's 1 divided by 20. So I can fill that in. And 2 divided by 20 is 1/10, so that's 0.10. I have a couple of those. 0 divided by 20 would be 0. So we have 3 zeros in a row. 3 divided by 20 is 0.15. So we have 2 of those. And finally, 5 divided by 20. If we reduce 5/20, that's 1/4, so 0.25 is the probability. All right, there's step 2. We've got our frequency distribution and probability distribution table for the data. So this is really combining question 2 and 3. Question 4, what value of x is most probable? So look down your probability column and find the highest value, and that would be 0.25. So that means the x value of 12 is the most probable. For number 5, what is the probability that x is greater than 10? So we're looking for the p of x greater than 10. In order to calculate the probability of x greater than 10, we go back to the table. To be greater than 10 means it is not equal. It has to be larger. So the only numbers we have that are larger would be the 11 through 15. So these are the probabilities that fall in the category of greater than 10. So all we need to do is add those up. So the probability that x is greater than 10 is equal to the sum of these probabilities. So 0.5 added to 0.25 would be 0.3. Add 0.1, that's a total of 0.4. 0.45 added to 0.15, and we're going to get 0.60. So the probability that x is greater than 10 is equal to 0.6. So we're just finding the sum. For number 6, what is the probability that our random number is 5? So we go directly to the table. Probability is 0. Number 7, what is the probability that our random number is equal to 12? So x value of 12 has probability of 0.25. Number 8, what is the probability of generating a sample that's -3? Well, if we go back to the original data, or just our x column, in fact, are there any values that are negative numbers here? None of them are -3, so there's no chance or 0 probability of our random sample including -3. If we go back to the original data, going to the honey column, looking down the entire column, none of these values are negative. And that's why the probability of getting a -3 in our random sample would also be 0, because none of the original measurements are -3. So that probability is going to be 0. Now number 9 we have to think about carefully. Find the probability that 6 is less or equal to x is less or equal to 13 and interpret the results. So what 6 less or equal to x less or equal to 13 means is the joining of two separate inequalities. One of them is a little more obvious to see, and that is x is less or equal to 13. So the other inequality is 6 less or equal to x. Now that's backwards from how we would normally write that. So if we trade sides with our terms and compare x to 6, it means we need to change the direction of this inequality to greater or equal. So if you think about a number line, number 6, number 13, we are really concerned with the numbers that are in between 6 and 13 and including 6 and 13. So numbers that are bigger or equal to 6 means we're including 6 with a bracket, shading to the right to go larger. But then numbers that are less than 13 would be going to the left, equal to it we'd use a bracket so you can see more clearly now that we're just concerned with numbers between 6 and 13 and also equal to 6 and 13. So I'll change my colors, go up to our table, find the value of 6, so that would be including the 0, and I'm going to go all the way down to and including 13. So you can see it's 0, 0, 0.15, 0.1, 0.1, 0.05, 0.25, and 0.10. All we need to do is add those probabilities. So we'd have 0 plus 0 plus 0.15 plus 0.1 plus 0.1 plus 0.05 plus 0.25 plus 0.1. So let's see, we've got 0.25, 0.35, 0.4, 0.65, 0.75 for our total. All right, just double checking, that is our total. So the probability of a random sample being between and including 6 and 13 is 0.75. And we're going to interpret the results. So the interpretation is there is a 75% chance of generating a number between and including 6 and 13. And the final question, number 10, says to construct a probability histogram for the probability of x. We'll have our probability, and then we'll have our x value. So I'll label probability and x. And again, we'll need to label our x-axis from 4 to 15. And looking at our probabilities, they range from 0 up to 0.25. So we can count by 0.05. The next step is to construct the histogram for each of our x values. So when the x value is 4, we have a probability of 0.05. For the x value of 5, we have 0, so that's not going to show up. And for 6 and 7, the same thing. There will be no bars for the histogram until we get to x value of 8, and then it will need to be 0.15 tall. For x value of 9, we're going to make our bar 0.10. For x value of 10, it's also going to be 0.1. For x value of 11, it's 0.05 tall. For 12, we have our tallest bar at 0.25. For 13, we have 0.10. And for 14, we have 0.05. And last, x value of 15 is at 0.15. So we have labeled the x-axis, but we should probably also write that that is the number, just have a title for that axis. So this is what our histogram looks like. From the histogram, you may want to write other details, like above each of the bars, you could write the probabilities for each of them if you wanted to do that, adding the details. It's also easy to see that 5, 6, and 7 have a 0 probability because there are no bars associated with those x values. And we can see that 0.25 is our highest probability. So having the picture sometimes really helps with understanding some of the other questions involved. And even if you're looking for a range, like greater than 10 or less than 7, it's going to be easier maybe to answer those questions once you have your histogram drawn.